An Earth-like planet orbiting an M-dwarf in the search for habitable worlds beyond our solar system. The biggest, hottest opportunities may be found around the smallest, coolest stars, called M-dwarfs. These stars have a mere fraction of the Sun's mass and luminosity, but are more than 10 times as numerous. The most common type of star in the universe appears to have no atmosphere at all. This discovery could cause a major shift in the search for life on other planets. In this video, we're going to discuss the discovery that could dramatically narrow our search for space creatures. The video is going to be amazing, so make sure you stick to the end. Before starting the video, be sure to smash that like button and subscribe to never miss out on any of our videos.
But NASA has just announced an amazing discovery on the sunlit side.
What makes this discovery so unusual is the sheer number of new worlds spotted in one go.
Astronomers have discovered a distant star with an unusual flickering pattern.
Well, it's all related to the Earth rotating around the Sun and the tilt of its axis.
More prosaic explanations, according to skeptics, of which there are plenty in the scientific community.
Because M-dwarfs are so ubiquitous, this discovery means a large number of planets orbiting these stars may also lack atmospheres and therefore are unlikely to harbor living things. The work that led to the revelations about the no-atmosphere planet named GJ1252b is detailed in the Astrophysical Journal Letters. The star has an apparent magnitude of 12.0 with an absolute magnitude of 10.5. GJ1252b is a super-Earth exoplanet that orbits an M-type star. Its mass is 1.32 Earths, it takes 0.5 days to complete one orbit of its star, and is 0.00915 AU from its star. Its discovery was announced in 2020. Since this planet is so close to its star, it receives a lot of heat, and that proximity is deadly in another way. The heat from the star renders this world inhospitable. This planet orbits its star twice during the course of a single day on Earth. It's slightly larger than Earth, and it's much closer to its star than Earth is to the Sun, making the J1252b intensely hot as well as inhospitable. The pressure from the star's radiation is immense, enough to blow a planet's atmosphere away, said Michelle Hill, UC Riverside astrophysicist and study co-author. Comparing the eclipse measurement to a large suite of simulated planetary spectra indicates that GJ1252b has a surface pressure of less than or equal to 10 bar, that is substantially thinner than the atmosphere of Venus. Earth also loses some of its atmospheres over time because of the Sun, but volcanic emissions and other carbon cycling processes make the loss barely noticeable by helping replenish what is lost. However, in greater proximity to a star, a planet cannot keep replenishing the amount being lost. In our solar system, this is the fate of Mercury. It does have an atmosphere, but one that is extremely thin, made up of atoms blasted off its surface by the Sun. The extreme heat of the planet causes these atoms to escape into space. To determine that GJ1252b lacks an atmosphere, astronomers measured infrared radiation. Infrared radiation IR is electromagnetic radiation EMR with wavelengths longer than those of visible light. Infrared radiation is also referred to as heat or thermal waves or electromagnetic waves from the planet as its light was obscured during a secondary eclipse. This type of eclipse occurs when a planet passes behind a star and the planet's light, as well as light reflected from its star, is blocked. The radiation revealed that planet's scorching daytime temperatures estimated to reach 2,242 degrees Fahrenheit, so hot that gold, silver, and copper would all melt on the planet. The heat, coupled with assumed low surface pressure, led the researchers to believe there's no atmosphere. Even with a tremendous amount of carbon dioxide, which traps heat, the researchers concluded GJ1252b would still not be able to hold on to an atmosphere. The planet could have 700 times more carbon than Earth has, and it still wouldn't have an atmosphere. It would build up initially, but then taper off and erode away, said Stephen Kane, UCR astrophysicist and study co-author. M-dwarf stars tend to have more flares and activity than the Sun, further reducing the likelihood that planets closely surrounding them could hold onto their atmospheres. It's possible the planet's condition could be a bad sign for planets even further away from this type of star, Hill said. This is something we learned from the James Webb Space Telescope. The James Webb Space Telescope is the largest, most powerful space telescope ever built. It will allow scientists to look at our universe was like about 200 million years after the Big Bang, which will be looking at planets like these. Hill's work on this project was supported by a grant from the Future Investigators in NASA Earth and Space Science and Technology program. There are 5,000 stars in Earth's solar neighborhood, most of them M-dwarfs. Even if planets orbiting them can be ruled out entirely, there are still roughly 1,000 stars similar to the Sun that could be habitable. If a planet is far enough away from an M-dwarf, it could potentially retain an atmosphere. We cannot conclude yet that all rocky planets around these stars get reduced to Mercury's fate, Hill said. I remain optimistic. One reason M-dwarfs are so numerous is that they imply live longer than other stars, their numbers growing over time because their small size allows them to slowly and efficiently burn their nuclear fuel. But this longevity comes only after troubled youth. Somewhat counterintuitively, because of their small size and weaker gravity, M-dwarfs can take longer to form than much larger stars. They can spend hundreds of millions of years as protostars, slowly forming from the collapsing clouds of gas. Planets, however, may form around such a protostar in only tens of millions of years. In all the intervening time, those worlds would broil in the protostars' light and heat, possibly cooking off most of their life-giving water before the M-dwarf was fully formed. On Earth, we live in the troposphere, the closest atmosphere layer to Earth's surface. Tropos means change, and the name reflects our constantly changing weather and mixture of gases. Venus is similar to Earth in several respects. Its density, size, mass, and volume are all comparable. The atmosphere is where the similarities end, however. The atmosphere pressure is around 92 times that found at sea level on Earth. The atmosphere of Mars is, much like Venus, composed primarily of carbon dioxide. Jupiter is the first of the gas giants and the largest planet in the solar system. Its atmosphere is, interestingly, fairly similar to the composition of the Sun. Much like Jupiter, the upper clouds in Saturn's atmosphere are thought to be composed mainly of ammonia ice, with clouds of ammonia, hydrosulfide, and water lower down. The atmosphere of Uranus is, like Jupiter and Saturn, mostly hydrogen and helium. However, the slightest higher levels of methane, particularly in the upper atmosphere, cause greater absorption of red light from the Sun, in turn causing the planet to appear a blue cyan color. As with Uranus, the blue coloration of Neptune is partially a consequence of the presence of methane. However, as Neptune is a deeper blue, it's thought that some unknown constituent of the atmosphere must also contribute towards the color. Pluto hasn't been a planet for a fair few years now, but that's no reason to leave it out of the fun. Meanwhile, scientists are identifying some chemical traces in the atmospheres of exoplanets. When those planets cross in front of their host star, a tiny amount of the star's light passes through the atmosphere. Some of that light can be absorbed by atoms or molecules in the exoplanet air, leaving a distinct spectral signature. That doesn't tell us the entire chemical composition of the planet's atmosphere, but it can reveal water or other important molecules. The next generation of telescopes includes telescopes specifically designed to look for oxygen, water, and other potential signs of life in exoplanet atmospheres. Additionally, observers have seen signs of stellar weather affecting exoplanets. Radiation and particles from stars can puff up exoplanet atmospheres and, in extreme cases, strip the air away entirely. Many known exoplanets orbit active stars, which produce powerful flares. Let us know your opinion in the comment section down below. This was all for today. Hope you liked the video. Don't forget to subscribe to our YouTube channel. Stay safe, and we'll be back soon with another video just for you guys. Until then, take care, stay safe, and be happy, guys.